Hi, folks. Welcome to 8.6 and 8.7 parametric equations and graphs. And so in this video, we're going to take a look at what it means to be a parametric equation, how to work with it, and maybe also some uses of it. So let's start with what we know. Okay, so far in this chapter 8, we've gone through quite a few different applications of geometry. And so, for example, we've learned how to handle non-right triangles, right? We've looked at law of sines, law of cosines. They allow us to find angles and sides in a triangle that doesn't have to be right. And we've learned also how to find the area of triangles that aren't necessarily right triangles, okay? We've also taken a look at polar equations. And so with the polar equations, we've learned to convert between polar and rectangular points and equations. We've learned 3 special kinds of graphs that would be useful for us to remember the form, right? We learned how to predict what those look like just from the equation and actually confirm it with a graph. And then we started to look at the polar form of complex numbers. All right, so we've done quite a bit so far. And in this section, we're adding on to that. All right, we're going to be taking a look at parametric equations. And in particular, we're going to focus on graphing them, how that works. We're going to be converting between parametric and rectangular equations. All right, and I want to add a little note here for this. This is often referred to as eliminating the parameter. Okay, so when we're looking at converting from parametric to rectangular, we often call that eliminating the parameter, right? And lastly, we're going to focus on some special cases of parametric graphs so that we can sort of, just like we did with polar, we can predict what a graph is going to look like just based on the equation, okay? All right, so that's our what we know and what's new. Let's move on to what are parametric equations, okay? So what are parametric equations? Here's a definition. The graph of the ordered pairs xy, where x is f of t and y is g of t. All right. If these functions are defined on an interval of t values, then we have something called a parametric curve. The equations are the parametric equations. So these are the parametric equations. And if you're wondering why they're called parametric, because t is what we call the parameter. Okay, so these t's are what we call the parameter. Now, you might be sitting there asking yourself, why are we learning about something that seems to be making things more complicated, right? And I'm going to talk a little bit just about one of the primary uses of parametric equations, okay? So let's say that we have an object that is moving through space. Now we're going to be focused on 2D, but when you get to Calc 3, you can actually expand this to a 3-dimensional situation, okay? So let's say something is moving in space. It has a direction, right? And one of the things that parametric equations can tell us is the direction with which something is moving. So that's pretty cool, okay? We can learn about direction. Now, this graph that I just drew is a line, right? And we know that's a y equals mx plus b, so maybe that's not super exciting. But what if we had something that was moving kind of like this, right? And in fact, what if it was moving in this direction? How would we write an equation for something like that, right? That seems really complicated. When we have something like the line, we can just say y equals mx plus b, but how would we write an equation for a more complicated motion, right? So that is one of the more important uses of parametric equations. It allows us to actually track how things are moving over time by breaking it up into horizontal movement and vertical movement. okay? Meaning we could take this graph and break it up into all the pieces that are going horizontally and all the pieces that are going vertically. And then that would allow us to actually figure out how to write an equation for this and then maybe use that equation for something else, okay? So lots of uses for parametric curves and equations, but we're going to start with the basics, okay? So the focus of this video is going to be graphing parametric equations using tables, and we're going to go through 2, maybe 3 examples for this, okay? So we've got these 2 equations here. I'm going to use 2 different colors so we can sort of keep track, all right? But we're going to have our x equation. We're going to plug some t values in and put those down the x column. And then we're going to go ahead and take the y equation. We're going to plug those t values into the y equation. We're going to get some y values. And you might be wondering, well, what values are we plugging in? In this case, we are plugging in -2 all the way to 3. Okay, and so when I'm plugging in -2 to 3, what makes sense here is to go by whole numbers, okay? And we'll talk a little bit about in the next equation when you might know that you're not going to use whole numbers, all right? So let's take the -2. We're going to plug it into the x equation. So -2 squared is 4. 4 minus 3 is 1. All right, and I'm going to keep doing the same thing for the other values down the column. -1 squared is 1. 1 minus 3 is -2. 0 squared is 0. 0 minus 3 is -3. And if I keep going, I should get -2, 1, and 6. Okay. All right, we're going to do the same thing now for the y values. I'm going to take all of these t's and I'm going to put them into the green or the y equation, okay? So 2 times -2 is -4, plus 1 is -3. -1 times 2 is -2, plus 1 is -1. 0 times 2 is 0, plus 1 is 1. And then 3, and then 5, and then 7, okay? All right, so now let's plot the points to sketch the graph. We have to, however, include the direction. We have to include arrowheads so that we know which direction our curve is going in, okay? Because something that goes in this direction is going to be different than the same thing but going in the other direction, okay? All right, so let's plot these points. The first point I'm going to plot is 1, -3. So 1, -3. I'm going to go ahead and plot all these points: -2, -1, -3, 1, -2, 3, whoops, 1, 5, and 6, 7. And I'm going to connect those with a nice smooth curve, right? So I've got something kind of like this, something like this, and we're actually going to stop at the ends. So what I don't want to see is arrows, okay? The reason we're not putting arrows there is because all we're doing is saying, I just want the piece of the graph between -2 and 3. This is the piece. Now, how do we know what order we graph it or we draw the arrows in? We think about the order in which we plotted the points. So we started here, we ended here, so our arrows are going to go this way, okay? You don't need to draw 20 arrows, but more than 2 would be nice. So make sure it's enough so that your reader knows very clearly which direction your curve is going in, okay? And there you have it. You graphed your first parametric equation. All right, now, if you'd like, now is a good time to pause the video and try number 2 on your own, okay? But if you would like, we're going to go over that one together right now. So we've got our y equation. We've got our x equation. All right, we'll do our mental math here. 2 times -1 is -2. Now, why would I choose some fraction values when I'm only trying to go from -1 to 2? Well, one of the reasons is I might want to get a few more points in there to make it clear what the shape is. But the other reason is I think it's good to practice, like, how do you pick nice numbers? And by nice numbers, I mean like things that might give us a whole number output, okay? So -1/2 times 2 will give me -1. And then 0, 1, 2, and then 3 and 4. Okay. Now, if I take these same t values and I plug them into the green equation, I am going to get some decimals. And that's part of this layer too, okay? I think sometimes when we work with decimals or fractions, we just get a little nervous. And I think it's important to keep our brain fresh with like how we do those numbers in our head, okay? All right, so let's start from the top. -1 squared is 1. 1 minus 1 gives us 0. -1/2 squared, that's going to give me 1/4 minus 1, which is 3/4. Or sorry, -3/4. Okay, I plug in 0, I get -1. I plug in 1/2, again, I get 1/4 minus 1, which is -3/4. I plug in 1, I get 1 minus 1 is 0. 3/2, let's see, 3/2 squared is 9/4 minus 1, which is 5/4. And then when I plug in 2, 2 squared is 4, 4 minus 1 is 3. Okay, so a good exercise in mental math and practicing that. And now we're going to go ahead and plot our xy pairs. So -2, 0, -1 and -3/4, 0, -1, 1 3/4, 2, 0, 3, 1 1/4, and 4, 3. All right, now if we connect these, again, we're not putting an arrow on the end, but rather we're putting some arrows on the actual curve to show that we know the direction. But the reason why we don't put any arrows on the ends is because we are only taking the slice from -1 to 2, okay? All right, so that seems like a good place to stop this video just about graphing, and come on back in the next video. We're going to start to see how do we graph, but how do we also do that eliminate the parameter thing, okay? All right, I'll see you folks back here.